Welcome everybody. My name is May Kassar and I'm the Director of the University for Sustainable Heritage. And Carl Heron from the British Museum is with us this evening. And this is one of a series of lectures held in memory of Nigel Seeley. You'll hear more of him anon from Carl. Today's exciting lecture, an intriguing one, is called Molecules at the Museum. You can read the rest of the title behind me. But I'd like to tell you a little bit about Carl, who is the Director of Scientific Research at the British Museum. He took up this appointment in 2016 after spending most of his career in academia at the University of Bradford. He was head of the Department of Archaeological Sciences from 1999 and 2001, and if that wasn't enough, again from 2010 to 2014, and Dean of the Archaeological, Geographical and Environmental Sciences from 2001 to 2006. His research focuses on the molecular and isotopic analysis of trace organic matter associated with archaeological materials. In his lecture, Carl will highlight the impact of recent molecular investigations of museum samples in terms of their contribution to the study of the past. The implication of these studies from the viewpoint of sustaining collections for future generations will also be explored. After the lecture, Carl will obviously take questions, and then we'll all join together for informal drinks upstairs. But for now, over to Carl.
Okay, thank you very much, May, and well, thank you to you all for coming this evening. I am going to give a talk, as to May said, about sort of molecular analysis and its application to mainly archaeological material. I'm an archaeologist by training. I've been in post in the British Museum for 1 year and 2 days, and this was a selfie that I took at the end of my first day at the British Museum in March 2016, and I don't think I've aged that much in the time since then. I've had a very interesting and exciting year in the museum. It's my first job working in a museum context. Before that, as May said, I spent most of my career at the University of Bradford, where I lectured. I took up my post there in 1990 and stayed there for 25 years before I moved here. And this is a picture, and this is the last of my sort of home photo album. This is the academic staff and external examiners in 1991, and it was the first time that I came across Nigel Seeley here when he was working at the National Trust. And I met Nigel on a number of occasions over the years that he worked at the National Trust. Our research wasn't particularly congruent, but we had a number of opportunities where we could meet together. If you're wondering, this is me here at the back with a rather unhealthy head of hair. Yes, so I think it's really nice that the Institute for Sustainable Heritage has the lecture series in honour of Nigel's name and contribution to conservation and conservation science. So I'm going to break my talk down into 3 parts. I'm going to sort of introduce the scope, history and context of molecular or biomolecular applications, particularly to, as I say, to archaeological material. I'm going to give a case study where it draws on museum samples. It's something that I suppose in my transition from a university context to a museum context, it's interested me a lot, the nature of sampling from museums. And then my part 3 is just to conclude on some general observations and perhaps some directions and ways forward, and that's where I hope the discussion will begin. So the term biomolecular archaeology hasn't been around for that long. But from Terry and Kerry Brown's book in 2011, they identified a number of different sort of molecular-based approaches that can be applied to a very wide range of materials. And perhaps some of the most heralded applications are in the field of DNA and a wide range of animal tissues, of soil sediments, plant tissues and so on, can act as potential substrates for DNA sequencing and phylogenetic analysis. Proteins also, a very wide range of opportunities for accessing ancient proteins. My own area is in the field of lipids, sort of smaller molecules and their applications in particular kinds of contexts, and perhaps the Cinderella, I suppose, perhaps of the carbohydrates that have been not so carefully studied, although a number of applications have been focused on the study of starch grains and starch granules associated with archaeological material. And I like using the book cover as a medium to show how fields develop. And back in 1994 was, I think, pretty much the first volume that was dedicated to ancient DNA, and museum specimens featured quite prominently in that edited volume, Herman and Hummel, from 1994. By 2001, Martin Jones had written a popular book called The Molecule Hunt, Archaeology and the Search for Ancient DNA. By 2011, we have textbooks in the subject, so feeding through into teaching, both undergraduate and postgraduate teaching. And then by 2014, we have the autobiographies of the key protagonists in the field. So Svante Paubo's book, Lost Genomes. He's director of the Max Planck Institute, one of the Max Planck Institutes in Germany, in Leipzig. And so you can see an intellectual trajectory of these different kinds of applications and approaches. In terms of giving an example of the scope and range of biomolecular investigation, one example might be the so-called Iceman or Ötzi, and this was the Neolithic body that was recovered from the Tyrolean Alps in 1991, exceptionally well preserved, and is on display in the South Tyrol Museum of Archaeology in a refrigeration temperature at minus 6 degrees. But it's probably one of the most studied human bodies that's ever lived. And some of the applications of molecular investigation can be seen here. So a wide range of different kinds of DNA to the tissues, so looking at the body itself, but also pathogenic DNA that was associated with the oral cavity, with the intestinal tract. Lipid investigations of the skin, looking at the depositional context of the body and post-depositional change, proteins associated with brain tissue, also a wide range of isotopic analysis, both dietary work and also looking at the mobility, where the individual had perhaps moved from before his death and deposition. And in addition to the body itself, a wide range of applications have been undertaken on the material culture associated with the Iceman. The analysis of glues, of hafting materials on the axe, and even of blood residues that were found or claimed to have been found associated with the specific material culture categories. So for some, and indeed for myself, one may see biomolecular archaeology as a relatively recent phenomenon, but actually there is a long history of applications of molecular archaeology to museum materials. And if I give the example of paleoserology, that of the study of ancient blood groups, in 1900 Karl Landsteiner came up with the ABO system of classification, and the Hirschfelds, working during the First World War and immediately after the First World War, studied blood group frequency and begun to identify differences among different populations, largely of First World War soldiers that were brought together in Macedonia during and after the conflict. And within a very short space of time, blood group typing was applied to archaeological material, to museum-based material. And it was largely carried out in North America. There was some work here that was done a little later. And the key player in the field was William Boyd. He was a very eminent immunologist, biochemist. In fact, he was the first professor of immunology in a university in North America. He was at the Boston Medical School, Boston University School of Medicine, and he worked with his wife. So he was a very eminent researcher in the field of blood group analysis. And even as early as 1937, the Boyds had obtained no fewer than over 300 samples from Egyptian and American mummies to apply blood group testing. And the area of application here was looking at family groups, was looking at population groups, kin groups, and so on. It was fairly destructive analysis. They were taking between 0.2 and 0.3 of a gram of tissue in order to check for the blood group type, look for the precipitation. They used the so-called precipitin test. That work was published. Boyd published a wide range of papers in the 30s and 40s. But by the 1950s, blood grouping in archaeology had been rather called into question. There were significant problems with bacterial antigenic substances that would also give reactions and lead to false positive tests. Also, the breakdown of the oligosaccharides on the surface of the blood, the red blood cells, were also changing in rather complex ways. And a lot of the work on blood groups was eventually called into question and largely rejected, and superseded, at least on archaeological material, largely rejected, and superseded subsequently, eventually, by DNA sequencing. Boyd was an absolutely fascinating scholar. He wrote a number of textbooks. He was very keen on writing science fiction, and he wrote it under a pseudonym, Boyd Ellenby, and he was great friends with Isaac Asimov, the science fiction writer, who was also a professor of biochemistry in the same University School of Medicine. And they published a book together in 1955 called Races and People. And they were very liberal. Asimov and Boyd were very liberally minded individuals, and they attacked the whole notion of race as it was articulated in the 40s and 50s. It's a very liberal book, and it's still cited today by some in North American contexts. Bringing us right up to date with research, this was a paper that was published last week, and it was published in the journal Nature. And I think it just illustrates the potential impact of molecular investigations, again, of in this case, recently excavated material. This was Linda Way-Richards' work with a wide range, a number of co-authors. And this was looking at calculus. This is the deposits plaque, which accumulates on teeth, and a number of Neanderthal specimens from European sites, including the very famous site of El Sidró in northwestern Spain, and these samples are from the Cave of Spee in Belgium. They looked at DNA sequences, DNA sequence recovery from samples of calculus from the teeth, and they compared the diets of individuals, of Neanderthal individuals, compared and contrasted the dietary signals that they could recover, and not only suggested dietary intake, they also suggested the ingestion of medicinal plants as part of the spectrum of DNA that was recovered from the calculus. So poplar, they had sequences consistent with poplar and sequences consistent with Penicillium fungus, suggesting the potential for looking at not just a dietary intake but of medicinal plant intake too. I was particularly struck by the dedication. One of the co-authors, Keith Dobney, worked very closely and was taught by Don Brothwell, who was an academic at the Institute of Archaeology at UCL, and they dedicated to Don Brothwell's contribution to the field. And that interested me a lot, because I'm very interested in the history of the subject. And Don Brothwell also worked at the Natural History Museum. And this is a picture of Don Brothwell. This was published, he died just last year, Don, after a very illustrious and distinguished career in archaeology and bioarchaeology. And he published a wonderful autobiography last year in 2016, which included a number of pictures. And this is Don Brothwell here in 1965, working on the first scanning electron microscope in the Natural History Museum. And what did Don Brothwell study in the 1960s using scanning electron microscopy? He was looking at dental calculus associated with specimens in the Natural History Museum. And he was able to detect the potential possible calcified microbes. These are not great images, they're just scanned from the book. And also some degree of microstratification within the calculus itself, suggesting that it was a potential substrate for other kinds of information, which is now coming to fruition through the wide range of DNA, protein and lipid investigations that's being undertaken on this particular material. I wanted to just, before I go into my case study, just mention a little bit about the potential of museum specimens to enable us to reevaluate and reconsider and review our assumptions and perhaps challenge our assumptions about the nature of the material in the collections. And this is a study, I plucked this as a study from the scientific research team in the British Museum. Two of my colleagues, Rebecca Stacey and Pauline Berger, who was a Marie Curie research fellow in the museum for a couple of years. And this is on work from Sutton Hoo. And this is on the identification of these very small, and these are very small, this is a 5mm scale, if you can just make that out, very small lumps of these black amorphous materials. And the assumption had been, and a limited analysis had been undertaken, the assumption had been that these were part of the waterproofing, part of the caulking of the boats, the ship's timbers, of the excavation of the boat burial. Remember, the excavation of the boat burial took place in 1939. The archive, many of the finds are in the British Museum, and some limited analysis using spectroscopy had demonstrated that it was probably a pine tar from pines grow abundantly in northern Europe, and that pine tar had probably been produced to waterproof the ship's timbers. Colleagues were doing a project on tars and pitches associated with a range of materials in the collections, and they didn't identify pine tar from the analysis. They identified bitumen, a petroleum product, a liquid semi-solid petroleum product. And they were able to establish, using geochemical fingerprinting techniques, both isotopic and molecular, to identify the origin of that bitumen as from Syria, as coming from the petroleum outcrops in Syria, suggesting that the material had been moved over very, very long distances. They looked at the British bitumen sources. The data were not consistent with a British origin. The data were most consistent with an origin in the Middle East. And that helps us to re-evaluate the origin of the material, the nature of the material, and prompts a re-evaluation of the interpretation of why that material is associated with the Sutton Hoo ship burial. Just going on to my case study then, this is some of my own research that I've conducted with a range of museums over the last few years. And I called it the unknown unknowns in museum collections, the things we don't know, to use Donald Rumsfeld's parlance and quote. A few years ago I had the privilege of being involved in a project on late Roman sarcophagus burials from a site in Germany, from Trier, St. Maximin's, and these are 4th century AD sarcophagus burials, and these were particularly well preserved. And my interest was the amorphous organic substances that were associated with the burials. You can see the body here, and there were textiles here, woolen textiles, and some of the woolen fibres had gold wrapped around them, and also associated with the textiles are these abundant organic substances, which my colleagues in Germany thought might be resin, a natural organic resin, and got in touch with me to see if I might be able to identify that material. But I became very interested in how widespread this phenomenon was. Is this an indication of high status burial across Europe? There were several other indications of these sorts of burials, but very little evidence in the UK. So surveying the whole of late Roman burial in the UK, there was virtually no evidence of the occurrence of this particular burial rite. So did it not stretch into Roman Britain? Was it only a burial rite that involved resin, gold, textile associated with continental Europe? So I scanned the literature and came up again looking, delving back into the archives to a certain extent, and came across work that Michael Faraday had conducted in the 1830s on some excavated material from these mounds known as Bartlow Hills in Cambridgeshire, where an antiquarian called John Gage had excavated these mounds and recovered a range of materials, including this rather nice glass cremation vessel. And also, according to John Gage's letter to Michael Faraday, fragments of plaited basket work with a white coating inside. And he sent a range of materials to Faraday. This is a fascinating period, because Faraday at this particular time, 1831, was when he was devising the principles of electromagnetic induction. But he was incredibly interested in the study of the past. And a lot of antiquarians were sending Michael Faraday samples that he then conducted analysis on. And in Faraday's letter to Gage of 1832, and he did the analysis within a few weeks, which I think is really remarkable when sometimes we send stuff for analysis and it takes so long to get a result. But this substance is an odoriferous gum resin. When heated, it evolves a fine aroma somewhat resembling that of myrrh or frankincense, and at a higher temperature it burns with a white smoky flame. So that resonated with some of the resinous deposits that we were finding in some of our continental European contexts. So again, a little bit more work, and I came across a child burial, a very isolated, not part of a cemetery, from Arrington in Cambridgeshire. This was excavated in the late 80s, and this is the lead-lined coffin. It's about 1 metre in length. I won't go into the details, but pieces of resin were discovered from the burial, alongside bone, hair, some textile, and also some putative plaster from the burial too, and these rather nice pipe clay figurines here. So I set about trying to... I should say that the Bartlow Hills resins were no longer available, they were lost. So both from Faraday's work and from John Gage's work, there was no way that I could recover those original samples and conduct analysis on the samples that Faraday had worked on. So that's why I had to look elsewhere. And I found, I had a visit to the Museum of Archaeology and Anthropology at Cambridge, and they helped me find, it took a little while, but we did find it, the samples of resin that had been recovered from the Arrington child burial. So that provided the very first sample in the UK that I could potentially look at. And this is my letter, my application that I made for a sample. I asked for a small sample of 5 to 10 milligrams of the sample, and I said that more than 95% of the original sample by weight will remain untouched. The sample will be analysed by gas chromatography, mass spectrometry, and this is destructive analysis. And it took a while, and it did take a while. I then submitted the formal application, but permission was granted. So by that time, I got so excited that I thought, I'm going to do a whole project on exotic resins in late Roman burials from UK sites. And I got a PhD student, was funded by the Arts and Humanities Research Council, and a PhD student was enlisted to work on one sample, which was what we had in our armoury at that particular time. And the challenge was, well, is it possible to expand that database? So we analysed the sample. The Arrington resin was exceptionally well preserved. This is just gas chromatography, mass spectrometry data on the principal molecules that we recovered from this particular sample. And I work a lot on natural resinous samples, and we were able to get a really nice match with a very specific triterpenoid resin from the genus Pistacia. And it hadn't changed that much. It didn't appear to have been heated. It was still the sort of golden yellow colour of the original resin that exudes from the tree. And the interesting thing about Pistacia resin is it doesn't grow in UK or Northern European contexts. It grows in Southern Europe, Greece, Turkey, Levantine coast, and North Africa. So it's a resin that was travelling over great distances to be incorporated into a burial in the 2nd century AD in the UK. This is an example. This was a friend who went to the island of Chios in Greece, where Pistacia, mastic resin as it's known, very, very well known in this part of the world, collected from the trees and has been used for hundreds of years by the inhabitants of the island of Chios. It grows much more widely, or other trees of the Pistacea genus Pistacea family grow much more widely over the region that I mentioned. So from that, I gave a challenge to my PhD student to say, well, widen the sample. If we have one example of a resin that survives in an archaeological context from a UK site, let's expand it out and see if we can increase the number of samples and build up a better picture of this particular analysis. So I won't go into too much detail about that. I'm going to focus on what we decided to call coffin debris that some museums had actually kept. They had kept the kind of material that had been scraped out of the base of a stone sarcophagus, and it had just been bagged up. Not with any particular project in mind, I suppose, waiting perhaps for researchers to contact them with ideas to perhaps undertake some analysis. And we did. We contacted, this is the Dorset County Museum, the Dorset Natural History and Archaeological Society, and they gave permission for us to sample this so-called coffin debris, which is soil, perhaps pieces of bone and pieces of plaster from the burials. And also we looked at deposits on human bone. So these were unusual sort of staining, but also sort of visible deposits that had accumulated on samples of human bone from the burials that we were looking at. And this is just a blow-up of those two images from two graves from the site of Allington Avenue, late Roman cemetery in Dorchester. And so we used those as our next sort of set of samples to see if we could expand that horizon of the material from the burial. So here we go, there's some GCMS data, rather nice peaks, and we began to identify a range of really unusual, again, triterpenoid compounds associated with the deposits, both from, this is from the coffin debris from one of the graves, and we could see that there was incredible similarity. This is from samples taken from a mandible, vertebra and humerus from one of the burials, and then an extraction from the coffin debris from another of the burials. And we were getting considerable overlap, considerable consistency in the molecular profiles that we were extracting. So we were able to identify those compounds. We could identify compounds 1 to 9 as identified in the chromatograms. We could identify those pretty confidently, tie them down to a particular triterpenoid source, and again use our resin database, our survey of natural materials to pin down the precise origin. Now in this case, our work suggested that the origin here was frankincense, so a gum resin. Pistacea is not a gum resin. Frankincense is a gum resin, so it has a high gum sugar component in addition to these rather distinctive compounds. It was not identical because this is from a Boswellia sacra, an authentic sample, and some of the major constituents, peaks 10 and 11, we didn't find, or we found in very, very low abundance, suggesting that the acetyl group had fallen off during the years of burial and that these molecules were not surviving, whereas some of the more robust molecular structures of the triterpenoids were surviving and could be matched really rather nicely to our authentic sources. So from rather unpromising museum material, we could extract some really rather important information about the nature of the material. What's it doing there? I don't really have a huge amount of time. You can talk to me over a glass of wine later if you wish. But we studied the reasons. We looked at, explored, or Rhea Brattel, my PhD student, did a wide-scale exploration of why the resins were being incorporated. And what's that to do with the ritual, the funerary process and the mortuary process. As important was the fact that we felt we could build a methodological sequence for how we might tackle these kinds of samples in the future. Nobody had really ever thought to study this kind of material from this kind of perspective. So we developed a methodological sequence starting with the nature of the material through visual inspection, looking to the amount of the sample that's required for analysis, and then the analytical techniques that are required to conduct that analysis, from non-destructive means through to the destructive methods of GCMS and ultimately GCC-RMS if that was required. And that brings me to sort of part 3 of my talk, which is around the whole issues of sampling and the acquisition of samples from museum archives. So my own area of research is looking at organic analysis of primarily pottery vessels. I have an interest in the relationship between organic substances that were used in pots through food preparation, through storage, through consumption of food, and recovering that information using a similar kind of operational sequence to the method that we developed for grave soils, for the coffin debris, and so on. And I've worked with a number of museums. This just happens to be one particular sample. These are sort of shallow oval bowls from the late Mesolithic, the sort of final hunter-gatherers or hunter-gatherer-forager economies of Denmark and northern Germany. And these, through ethnographic analogy, were called blubber lamps, and thought to have been lamps used for heating and illumination with seal oil was one of the kinds of organics that was thought to have been used in association with these particular vessels. In order to confirm that, we conducted a project, and it does involve destructive analysis. And this is my thumb, and these are my fingers in a blue nitrile glove, removing small amounts of the material from the inside wall of the vessel in order to conduct analysis to try and confirm the original contents of these particular pots. And yes, we went through formal sampling procedures with the museum in order to secure these samples for analysis. And this is just the sort of wider operational sequence, if you like, for studying pottery vessels. Sometimes we remove, as was the case with the previous side, we remove small samples from the inside wall, and on occasions we will drill into the ceramic material itself on the basis that liquids are likely to have seeped into the matrix of the pot during use. So it is destructive. We tend to take 1 to 2 grams of ceramic material, and these are extracted in the laboratory and then subject to gas chromatography, mass spectrometry, and other analytical techniques. And we have demonstrated it's possible to extract organic residues from pottery over very long time periods. And the earliest work that's been done to date is on incipient and early Jomon pottery from Japan. And some of the earliest ceramic containers in the globe are found in Japan, in China also, and in the Russian Far East. And the time frame of the vessels that we were looking at was 15,000 to 12,000 calibrated years BP. And the molecular analysis was able to identify a wide range of aquatic organisms, aquatic fats and oils associated with the pottery vessels from a range of sites. This was a project conducted at the University of York, and it took a significant period of time to build confidence and build relationships with the Japanese archaeologists and archive holders who had had their fingers burnt a little bit in the 1970s when Japanese scientists were very interested in applying these techniques and took very large samples from very, very rare specimens and destroyed them and never really properly published the results. And there were some interpretive challenges with some of the data at that particular time. So once burnt, it was very difficult to secure the samples, and it took, as I say, probably several years of collaborative research, quite a lot of experimental research to demonstrate that the techniques will work in this particular context on material of this age. If we widen out the nature of destructive analysis, taking DNA as an example, there are some interesting questions around the nature of sampling for molecular investigation. And this is a quote from Matthew Collins's work in 2009, which states that many rare and valuable ancient specimens now carry the scars of ancient DNA research, as questions of population genetics and phylogeography require larger sample sets. And a considerable amount of research has been trying to establish screening techniques. So are there screening opportunities or proxies that can give some kind of indication as to the likelihood of DNA survival in fossil specimens before they are actually sampled? But by and large, the screening techniques haven't tended to be widely adopted, partly because of the challenges of interpretation of the data sets. So this is Matthew's own work on using amino acid racemization that would only take very, very small samples of bone or teeth in order to try and work out from the racemization pattern of the amino acids whether DNA is likely to survive in that particular sample. But it doesn't work. Matthew's own research demonstrates that. Another alternative is whether non-destructive extraction of DNA is a possibility. So at the moment, the most widely used method for DNA extraction, and I should say doesn't involve such examples as is shown here, takes milligrams of samples, a few tens of milligrams, primarily from the petrous bone in the base of the skull. So it's taking very, very much smaller samples. But nevertheless, there's considerable interest in whether non-destructive DNA extraction has some validity, using buffer solutions to soak the sample and to remove DNA. And also there's been some success with proteins, of looking at ancient proteins using similar kinds of approaches. So the degree to which non-destructive versus destructive analysis is one that I think is very interesting and has some opportunity. And work that, again, Matthew Collins has done, looking at parchment, shows that there are opportunities where non-destructive analysis works reasonably well. I say non-destructive, I suppose minimally destructive analysis or minimally invasive analysis would probably be the most appropriate term. And this involves using a pencil eraser to remove very small samples using the waste from the eraser, which picks up electrostatically proteins from the parchment. And then those samples are then placed in the mass spectrometer using proteomics, can then be used to identify the species origin of the protein sample. And this was work that was undertaken, published in 2015, where it was possible to begin to look at the wide range of animal skins that had been used to fabricate pocket Bibles of the medieval period. In the British Museum, we have schemes that have been in place for some time, and all museums have, I suppose, a fine balance between collections care and access to the collections. We want to support research, and that can be destructive analysis of samples or non-destructive analysis of samples. And we have external examination requests. We have a process whereby external researchers can submit applications for access to samples in the collection. There are forms on the website, and we have to judge the applications that come in and evaluate whether we can permit the analysis of those samples based on the nature of the techniques, the nature of the objects in question, or the tissues, if it's from animal, human remains, so the nature of sampling in impact, a track record in terms of previous requests, of publication, of returning samples that were unused, of letting us know or letting us have the data so that we can incorporate that and we can update our collection databases. So it's very much an interactive between the external researcher and the museum itself. And I think it's a interesting question in terms of the nature of the dialogue, in terms of the way in which sampling is conducted. And just to finish off, several of us got together recently to think about how the wide range of different approaches, from DNA to proteins to lipids to plant microfossils and so on, whether there is any desirability in thinking through that operational sequence of the optimization of sampling of valuable materials within museum collections. So I organised a workshop recently on the 23rd of February with Philip Stockhammer and Matthew Collins, and we invited about 30 researchers from a range of institutions, including the Natural History Museum, the National Gallery, and a number of universities, of individuals who are working on different elements of molecular archaeology. And our kind of general principle was, what dialogue do we need to have to think about the sequence in which these analyses are undertaken? And what are the advantages of that particular approach, where we might do multi-analytical approaches on single samples? And potentially, are there disadvantages of that particular approach in terms of perhaps limiting analysis or limiting access of those samples to the larger research groups that can deploy the full range of analytical techniques? So we had a very interesting debate and discussion around those particular kinds of questions. And we will make available, we're going to be making available the slide database. We had a single presentation that we did via Google Slides. Everybody collaborated and worked together to produce one presentation. And we will make that available to the research community and invite responses on the kinds of issues and questions that we raised. And then just finally, there are resources and there is guidance available to researchers to support their analytical interests. And just to highlight some of these, the advisory panel on the archaeology of burials in England produced a document in 2013 called Science and the Dead. Very recently, it came out, it was published in January 2017. Historic England sponsored a document on organic residue analysis and archaeology, which includes considerations of samples. It includes where we are with the state of the art, what's possible through routine analysis, what requires a significant input of new research. The University of York have used YouTube as a way of communicating sampling strategy and sample destruction or minimal invasiveness of particular samples. And this particular video was produced in English and Japanese because it was the collaborative project with Japanese archives and museums, and publications that are trying to establish and recommend protocols for the protection of biomolecules within subfossil and archaeological material. This was a recent paper, came out last year, on recommendations for conventional micro-CT of subfossils and for synchrotron scanning of subfossils, so that the DNA is not damaged by the effects of the synchrotron beam. So I think I will leave it there. And they're my acknowledgements. So, and thank you very much for listening. Thank you.
Thank you very much, Carl. And we're open to questions now. If you could please indicate who you are and your affiliation when asking your question. Who'd like to go first?
Helen Gagnaris, Museum of London. Just wondering if you've seen any practice that conservators or finds processors have done on material that you'd rather they hadn't done that would affect analysis.
I can speak about my interest in sort of pottery vessels. I mean, the less treatment, the better. I think would be the argument where modern synthetic adhesives are used that can mask the analysis. Sometimes the damage is done in the field by excessive cleaning of pottery sherds and vessels when they come out of the ground. In some contexts, in Mediterranean contexts, where calcareous deposits develop on ceramic materials, they would place in 10% hydrochloric acid to remove all of those, and then excessively clean to perhaps get a real great view of the decoration on the vessel, but perhaps removing all trace of organic material that's associated with it. So the conservation laboratory is perhaps an end point of a whole series of issues to do with the nature of that material as it's removed from the excavation context. But certainly modern synthetics are a challenge. They don't completely negate analysis, but they're a challenge to deal with nevertheless.
Louise Bacon, retired, was a conservator. It's just a commentary. You mentioned the Blubber Hills. Have you tried Saffron Walden Museum? Because that's where a lot of the material is.
Oh, that's useful. Do you know, we haven't tried Saffron Walden, but we tried a number of places, a number of different leads, and Cambridge in particular, of course, don't have the material. But every lead that we took was that it had been lost, that it was no longer available. Gauges.
Yeah. Objects from the Blubber Hills. Yeah. And Faraday did a lot of analysis for the Saffron Walden Museum too.
Okay, that's really
things that were happening to their objects.
Fantastic. There's a great article by Gabriel Mashenko, who's in UCL and Institute of Archaeology, wrote a great article on Faraday's contribution to archaeology. He carried out a very wide range of analyses on pigments, on metalwork and organic material as well, in addition to being devising the theories of electromagnetic induction, electrochemistry. So, quite a contribution.
Patrick Quinn, University College London, Institute of Archaeology. I just wondered if you could elaborate on the question I emailed you about, which is the future, so the value, the curation, future of the scientific samples that are analysed.
Yeah, it's a really important.
Not touched on it.
Yeah, so
it's not in the guidelines at all.
Yeah.
Has everybody heard the question? No. Could you repeat it and
it's
raise your voice?
The status, the value, the ownership, and the future of the scientific samples that are extracted.
Yeah. So I know Patrick, and he got his retaliation in first with a question about a week ago on the nature of sampling and what we do with the samples that we've actually taken from objects. What happens to those? So I can talk a little bit specifically, then perhaps more generally. So in the British Museum, we keep all the reference samples that we take. So, for example, wood analysis, where we might take a tiny sliver of wood, that becomes part of our reference collection and is available then in perpetuity for comparing with new samples that come into the museum, samples that haven't been analysed in the collection. So from molecular analysis, I think it's an interesting question, and it's one that we didn't touch on a huge amount in our workshop at the Wellcome Trust, but we know when I grind up pieces of ceramic, I am by and large doing one particular method of extraction, by and large, to remove the lipids and then to analyse those lipid materials. We know that there's a lot of potential other organic material that might remain in the ceramic. It might be polymerized, it might be a little more difficult, a bit more recalcitrant and difficult to remove from the material. So the question is, do we keep the sample that we have extracted? Do we keep the powdered sample that we've extracted? We've analysed, we've hopefully interpreted the data, we've incorporated that into our data sets. Do we keep that powdered ceramic sample so that we can potentially conduct analysis in the future as techniques develop and improve? So the answer is, we by and large, we haven't been keeping those samples. But in discussions with Patrick, perhaps we should be keeping those samples. It invokes and invites all sorts of questions about storage, and that's, for those of us in museums, it's an enormous problem, an enormous challenge about where we put these samples, how do we curate these samples as people move on. I mean, I've worked in universities and people come and go all the time. And as a head of department, as a dean of school, one of my jobs was often to go into people's offices and into their laboratories where they had been based. And they had left huge amounts of sample behind them as they departed on to perhaps a new institution. So it's a major issue about the nature of the samples that have been worked upon.
The Japanese example, that they destroyed so much, and then they were cautious about allowing you to have some more. Then if there was a record of the amount of material that they took and ground up, then you could reanalyse that.
Absolutely. So in that example, example I gave, a Japanese scientists destroying large amounts of ceramic. In the 1970s, when this field had hardly got off the ground, and it's not just in Japan, it's in Europe as well, people were taking 100 grams of ceramic. So that the earlier studies were undertaken on large transport amphora, and people were just slicing the amphora, the large body sherds from these transport vessels, and were grinding down 100 grams of ceramic material. And that's similar to what was happening in Japan. So taking very, very large samples. So they really did bear the scars of the sampling process. But those samples were not available. They were just simply not available. Been taken into laboratories, worked on, and then nobody knew of their origin. But had they been kept,
future having some kind of plan, means that you can obtain samples without having to resample.
Yeah, absolutely. And this idea of the Wellcome Trust workshop of perhaps exploring how you can begin to bring together lipids, DNA, protein, if that's possible, with other analyses, is that if one analysis has been conducted on a given sample, then that sample may be available for subsequent analyses. And what's the sequence and what's the sort of order of process for that work to take place?
Any more questions? Yeah?
I've got a question.
Boris Pretzel, V&A.
Boris Pretzel, V&A. In the applied arts and fine arts, there's a lot of debate in different countries about the value of sample, the value of analytical information, and the value of the object. And there's very different approaches, very distinct American approaches, European approaches, Japanese approaches. Is that the same in the archaeological sciences? Do you get very, very different opinions about, is it worth taking a sample? Is the value of the scientific information more important than the value of the object? Is that a debate?
It's interesting. I haven't really come across that in the archaeological field. Certainly there is quite a lot of congruence in the methodologies that people are using. The kind of relative value is not of the nature of the sample versus the original object. Not something I'm terribly familiar with in the archaeological world. It's an interesting question. Not one that I have direct experience of.
So it's a little bit natural history. It's not an answer to the question, but the question back is if you can help us put a value on scientific specimens, we can answer that question. It's extremely difficult to put a value on archaeological or natural history specimens, unlike the fine arts where you have a Christie's and Sotheby's ready to help you.
You don't mean financial value, though, do you?
Well, actually, most things are measured in financial value.
Of course.
You need to comprehend. But,
Yeah.
it's a shorthand, not the real value.
Sure.
Thibaut Devies, University of Oxford, previously the British Museum. You explained the procedure to access to sample the collection of the museum. So I think you were talking about the objects. What about the reference collection, and particularly the reference collection in the scientific department? How accessible is this for other researchers?
That's an interesting question. I think in my first year, I don't think we've had any request to access the reference collection. We actually have an intern in at the moment who's helping us to classify and reclassify some of the materials in the particularly corrosion products, pigment and so on, to reclassify some of that. I don't know to what extent the reference collection is documented as a database, which would allow easy interrogation for external researchers. But in principle, especially for people that have worked at the British Museum, we could be thinking positively in that regard. But no. In terms of, I don't know the reference code. I think at the moment the ease of access of that material is probably the barrier, is the impediment at present. But if we can make it more widely available, the analytical data, the samples, then in principle, yes.
Any more questions?
Carl, you showed a slide where in the Museum of the South Tyrol there was a human body that was on display at -6 degrees. The ethical dimension of human remains on display. Could you comment on that in terms of your archaeological science work?
I mean, as I say, being in the museum for 1 year, I mean, I'm aware of the major kind of questions that it prompts. The British Museum published a really good book 2 or 3 years ago now called Regarding the Dead. And it was a wide range of how we curate the policies, the ethical questions of display, and the research that's undertaken on that material. And certainly within the British Museum, all of the evidence suggests that the majority of people who visit the museum are comfortable with seeing human remains on display. So we have a range of human materials, human remains on display within the museum in several different galleries. And it hasn't prompted we haven't had to have a major rethink of that, but we think very carefully about how it's displayed and in terms of how it's presented. And so we continuously have a process of thinking through the implications of that.
Is that communicated to your visitors? Do your visitors know how you actually curate and present human display?
Yeah, Regarding the Dead is available. The policy on human remains is available on the website, and the ethical policy for the display of human remains is also available on the website. Lindo Man is slightly, for those of you that have seen Lindo Man in the BP gallery, is slightly sort of off the main thoroughfare, so people can kind of choose to go to that specifically if they want to see that particular body.
Any final questions? If not, I think you'll join me for a round of applause to Carl.